Hi, everyone. The study I'm presenting is Community in the Loop, Creating Artificial Process Intelligence for Co-Production of City Service. Our use case is about the 311 system in Kansas City. It is a system that takes residents' requests of city services, such as trash in neighborhood, dead animals. The city will accordingly deliver services to the neighborhoods. The motivation of the study is that to solve a social problem, we need to channel the two-way communication and collaboration between communities and the city management. The challenge here is to use artificial intelligence and machine learning, deep learning to create a mechanism to bring the community in the loop. The solution is inspired by process intelligence. Process intelligence refers to the knowledge and the expertise of personnel structurally at the intersection between domain experts with knowledge about operational, curational, evaluative, and representational processes. For example, the nursing station in a hospital is the process experts who can route the problem to the problem-solving department. The motivation for automation is such role requires extensive institutional knowledge and is undervalued within organizational structure in comparison to domain experts with high turnaround rate. Training of such experts is expensive. Our problem statement is built upon the 311 system. The 311 system has two categorization systems. The external facing system collects information from the residents and understand their problems. This internal facing categorization system categorizes residents' requests into different service departments and problem categories. This dual system presents two major challenges to human operators and the AI support system that we're going to design. The internal facing categorization is often arbitrary due to legacy old categorization systems. The external facing system has the purpose of comprehending residents' requests. There is a semantic gap between the internal facing categorization system and external facing system. So the job of a 311 operator or the process expert in this case plays an important role to bridge the communication gap between the internal and external categorization system. And we built three models to support a 311 operator. The first model handles the communication with internal categorization system and answers two questions: who handles the problem and what happened according to the internal facing categorization. We used a fine-tuned BERT classification model to train categorization for the internal system. The second model is designed to channel the external communication with the callers. Answers two questions. Can you tell more what happened from the resident's perspective? We used unsupervised LDA plus BERT clustering model as a way to comprehend inductively the problems reported. The third model is built to facilitate a reciprocal communication between the 311 operator and the callers. It answers a question about when and where the problem will be solved. It's a time series forecast model. A little bit more about our clustering model. We used LDA to generate a local understanding, and as document embedding, we combine that local understanding with a more global understanding from sentence BERT. Our experimentation focuses on the balance between the dimension of the LDA document embedding and BERT sentence embedding, our results show that a balanced dimensions of these two sentence level, document level embedding produces the highest coherence score for the clustering process. We call our final model the balanced LDA plus BERT clustering model. Other results, our BERT classification model has achieved better performance than the other models. We also identified long tail prediction as a challenge to further improve the classification model on cases that have fewer instances in it. Our clustering model revealed a potential problem of the internal-facing categorization. We map the external categorization from the clustering model into the internal-facing categorization. We see that a significant amount of property maintenance and property violation problems are not categorized into the internal categorization systems for property maintenance and violation. There is a potential underestimation of such a problem in the neighborhood. The time series forecast model reveals a general trend of a steady decrease of time for service delivery. Beyond this study, this is the system that the process intelligence created in the study is going to support. The system will provide the 311 operator information on the residence problem and help the 311 operator to curate the problem into a internal problem solving department. The geolocation information and the nature of problem can be used to predict the delivery time of service so that the 311 operator can reciprocally communicate back to the callers about the progress of the problem solving process. So that is all about this study. Thank you for your attention.